Alright, let's get started on a couple of these. I'll try to do 4. That should easily put us at 30 minutes of time. So we're going to go over, that was funny, we're going to go over 1, 2, 3, 4 of these. So one of them deals with square root, one of them deals with subtracting polynomials, one of them deals with basically algebra, one of them deals with, it looks like number 12 here, which is more algebra. Let's start with some easy ones. So this is just multiplication of two polynomials, or it's just expansion of terms is what it's called. So I'll draw this out here. Let's see here. Alright, so product, let's do a refresher first. So for example, if we're just doing products of numbers, no values, right? If we have 3 times 3, right? That's easy, right? That's a product, right? So 9, right? Okay, so this is the product. Okay, so that's the part we're interested in, right? And then if we have something like semi-polynomial here, so we have one set of terms here, right? And then the terms in front of it, just to review, right? We can take that times a constant, right? A value, it's not a variable, right? Then we just expand them one at a time by multiplying each of them, right? So 3 times 3 gives us the first new term, which is 6, and 3 times 2, excuse me, and then 3 times 3, right, which is 9, and the x follows along. So you get, this is your new set of terms, one constant and a mixed term here with the constant and variable, so 9x's. Okay, now where people often struggle, I don't remember, I think we've gone over this before, right, is what if you're expanding out two expansion of a set of parentheses that has two variables in both parts, right? So here and here, so let's say, well, let me go back one step. Let's do this. Let's just do variable times single just to build up to. So we'll do the same as we did last time, 2 plus 3x, right? So in this case, again, it just expands to each one. So even though they're not similar terms, when you multiply, you still carry out the multiplication across. So this becomes 2x because we usually write the constant in front and the variable behind. You could write it like this, but people might get confused because they're not familiar with that. And then plus x times 3x just becomes 3. And then here's what's interesting. Remember, x times x, right? That's what this is right here. But we can simplify that because x times x we know can be written as 2x plus 3x to the second power because they're each to the first power. So when you multiply, you add powers. So this becomes 3x to the second. Okay, now let's do multiplication, a product of two portions in parentheses with variables. So for example, these guys, right? A minus 5 times A plus 3. Okay, so right off the bat we get some fun, and you might have heard FOIL, first, outside, inside, last. Okay, that's a common memory mnemonic used to identify how to do this, but basically you have to multiply everything times everything. Every term has to be multiplied. So the way you do that is I always start with this term and multiply it times both, and then I go to this term and multiply it times both. So let's do the front term first, and then we have to simplify and combine. So here we go again. We've got a times a, so as we just demonstrated, that's going to be a squared. And then we have a times 3, so that's going to become, again, we write the constant in front, 3a. And then we have, now notice this term here is one whole term. The negative goes with this term, so be careful. Here there's an invisible positive sign, right? So we just get lazy and we don't write the positive sign. But when there's a negative, we have to because it's inverse, it's opposite of the positive sign. So we express it with a little negative. So now this becomes negative 5 times a, right? Which again, the constant gets put in front, so negative 5a. And then we take negative 5 times, I'll do it down on the bottom so you don't get confused, times 3, so that becomes negative 15. Now, where can we simplify? Right? Well, the rules of polynomials, just to review, is we have to, any terms that have variables in them can be combined if it's the same variable or sets of variables and they have the same powers. So this is our only a squared term, so we can't simplify that. But here we have 3a and negative 5a. We can combine those because they both just have a, and it's just the first power. We don't write it because we're lazy, and many terms have first power, so we just don't express that written, but nothing there means first power. So 3 times 5 is negative 15, 15a. Okay, excuse me, not multiplying here, we're just adding. 3 plus negative 5, negative 2a. Okay. And then finally, this is the only constant term, so there's nothing to combine it with. So after we simplify, our final value is a squared plus negative 2a minus 15. Okay, you can express it like this, or minus 2a minus 15. So let's see if that's in any of the solutions, right? So it's in this guy, and we can check that real quick in the answer guide just to make sure. So this is number 12, and yeah, C. Okay. All right, great. So let's move on to the next one. So this is park commissioner designs a new playground in the shape of Pentagon. If he plans to have a fountain at every corner of the park, how many fountains will there be? So this is more just about translating words into numerical meanings that have value. So here they use the term Pentagon. So let me grab this real quick. So here he talks about a pentagon, right? So you need to know your names for the different numerals, okay? So 3, right, is tri, 4 is quad, right? And we can build all the way up to 10 here. Hold on a second. 10. Okay. So 3 is tri. You can remember that because you often deal with triangles. 4 is quad. 5 I'm going to come back to. 6 is hexagon. 7 is often sept. 8 is pretty easy to remember because of octopus, so octagon. 9 is non, and 10 is deca, and 5 is pent. Okay, so you can draw a pentagon then, now that you know what it means. Okay, and it has 1, 2, 3, 4, 5 corners. So if there's a fountain at every one, how many fountains are there going to be, right? So that makes this problem pretty easy. So it ought to be 5. And I'm checking the answer right now here. 14, yeah, B, so 5. Alright, let's move on and try to get 2 more knocked out here real quick. Okay, so this is nice because this is just more combination. So the first problem we did was maybe one of the hardest out of all of these. So right here we do combinations. So remember in the first problem we set up the multiplication, and then afterwards we simplified, which means we had to do some combining of like terms. Well, here there's no product, there's just subtraction, so it's basically just setting up the equation and then combining like terms. Since you have 3x squared minus 5x minus 1, right? The trick here is it has them in reverse order as you would in the operation. So it says, what's the result of subtracting this from this? So this is actually what all is going to become negative, and this goes on top. So 8x squared plus 2x minus 9. Okay, so we subtract that. So you can write them out on top if you want. And what's nice about this is stacking them up, you can see the like terms here. They kindly gave you very like terms in each, a constant, constant, mixed, mixed, and then mixed with as to the second power, mixed to the second power. So this all becomes negative though, so you can carry that multiplication out right now if you want, which I'll do for demonstration, right? So I take a negative times everything in here, so this becomes -3, right? So now I don't need that negative anymore. So I'm just, remember how we expanded? So I'm just taking that negative times everything in here, just like we did in the first problem, but this time it's with just a negative, like you can think of it as -1 if you want. So anyways, I'm just going to take that negative, okay, and I'm going to multiply it out to everything in here. So that becomes -3, this becomes positive, that becomes positive. So then you can add them, okay. So this is now -8. This, again, we're just combining down like this, like regular addition, becomes positive 7x, and this becomes 5x squared. So you can search your answers and see if that's an option. But this test has a lot of C's. So you check that, 5x squared. Let me check in the answer guide real quick. And C, number 4 is C, so that's correct. Alright, so let's do one last one for this video. Okay, so this is finding a square root. So to picture this, I would put it out in numbers so that you can then picture it. So what is a square root? Well, a square root is just the root base 2 of some power, right? So if we have x squared equals 9, right? We solve by doing the inverse, which is just square root of both sides, right? So we take the square root of this side, we take square root of 9, so this becomes x equals, right, 3, because this is the same, we could re-express this, right, as x squared equals 3 times 3, right? But that doesn't tell us what x is. So by implied here, by taking a square root, right, when we take the square root of this, that removes this, right, and therefore removes one of those terms, and we just get x equals 3. Okay. So what's weird is when they just give you the value, right, all the way up, and they say take the square root, you just start with this, right, and they're saying what is that equal to, right, question mark. So it's kind of the opposite of what we did before. So you can flip it around, right, and you can just say 85, right, and then the inverse is squaring both sides. Okay, so that gets rid of the square root, and now you have equals x squared. So essentially, what times itself equals 85? Okay, that's where this comes from. What times itself equals 85? I did some of that other earlier explanation. For some people that'll help. I'm not sure if that's your style. So you can just start trying with powers that you know, right? So what are some common ones that I know, right? So also this will be my squared column. So 4 squared, right? Sorry. This is x squared. So 4 is my x, so x squared is 16, right? Let's go up a little higher. Let's double it. 8. 8 squared is 64. So we're getting closer, okay? Let's go another step up. Let's do, let's do 10. So 10 times 10, 100. So what does that mean, right? So that means that our squared value we're looking for has to be somewhere between 8 and 10. Well, I'm kind of going the long way around this problem because you know it's got to be somewhere near 9 because all of these have 9 in the leading value there in the ones place. But what's different amongst all of them is the tenths position, right? So the really quick way to do this is just start with the best guess. So let's try 9.3. Let's see if 9.3 times 9.3, right? Let's see what that equals. So 3 times 3 is 9. 3 times 9 is 27. Okay, I need some room here. Okay, and then same thing, but you drop a 0, right? And so you ought to get a very similar value here. So it's going to be, let's see here. Actually, sorry, that was 3, so now we're dealing with 9. So 9 times 3, 27. Carry the 2, 7 down. And then 9 times 9, right? It's just one short, so that's 81. Okay, and then you had 2 decimal positions here, right? So we're going to put it here as our decimal point. So then drop this down. So what do we get? We get 83 point. I should start from the left because there is a value that's going to carry up. So starting on the right, excuse me. So 9, 4, carry the 1. So 2, 3, 4, 84.49. So that's really close to 85. Let's see if 9.4 can get us even closer. 9.4 times 9.4. I'm not going to have enough space there. Hold on. .4 times 9.4. So let's multiply that out. 0.4 times 0.4, or 4 times 4 is 16. Carry the 1. 4 times 9, right? So 36. And then similar, we're going to drop a 0. So 9 times 4 is 6. Carry the 3. I bring my 2 down in the other equation. I might have made a mistake. Let's see. So 9 times 9 is 81 plus 3, so 84. So I didn't bring down my 2 over here. So you can see right away, but this is going to be too much because 6, 2, 1. It's gonna be too much. So this is gonna be 88. So let's go back down. So 9.4 is too high. That means 9.3. I forgot to carry my 2 down here. So I'll do that again. This is what happens when I do math too late. So let me do this again. I'm thinking it's going to be like 9.1 or 9.2. So 3 times 3, already said it was 9. 3 times 9 is 27. Okay, and then 9 times 3 is 27. Here's my 2 I forgot to bring down last time. 9 times 9 is 81, plus 2 is 83. So this is going to put us over 85 also. So 6 and, or 0 and 9, 9, 14, carry the 1. So it's going to be 86. So we'll go down one more step. Let's go down to 9.2. Okay, so 2 times 2 is 4 times 2, 18. Bring down the 0. 9 times 2, 18. Carry the 1. I'll remember to add it. 9 times 9 is 81. So 82. Bringing down the 1. So now adding that all together with the decimal place. 4, 8 and 8 is 16. Carry the 1. It's 1, 2, 3, 4. So so this one is 484.64. So it says find the square root of 85 to the nearest tenth. So this one is the closest without going over. So 9.2 is actually looks like our winner. Let me check if I did the calculations correct. That's number 10. Yeah, B. So sorry I misdid this one at first. Okay. Now you're probably curious what that random picture was I showed at the beginning. Let's see if they can still find it. There you go. I yelped some puppies. That means we raised puppies, and when you have a mama puppy pregnant, you want to find out how many babies you have inside of her so that when she delivers, you know that all the babies have come out. So that was our puppy when she was pregnant with puppies. So we had to get an x-ray. So we had 3, you can see there are 3 little puppies in there. You just count the heads. So 1, 2, 3. All right, there you go. You have a good night.